Good afternoon, students. Once again, welcome back to Zoom class. Today I'm going to talk about energy flow and food chain, food web, and ecological properties. This is the topic that we are going to discuss. First of all, let me take energy flow. Actually, energy flow is a process by which transfer of energy from one trophic level to another trophic level. That is called energy flow. I repeat once again, energy flow is nothing but transfer of food energy from one trophic level to another trophic level. Actually, energy flow which flows only unidirectional. Right? It does not occur in bidirectional. Always energy flow is in unidirectional, which means the flow of energy, actually sun is the main source of energy to all the living system. Sun is the main source of all the living system for trapping of food, right? Here, the trophic level 1 are plants are T1. T1 is nothing but trophic level 1 that traps light energy into life energy, which means the green plants or the trophic level 1 are the members of T1 or trophic level 1 in an ecosystem which prepares a food material by utilization of light, carbon dioxide, water, mineral from the soil, right? With the help of all those raw material, this is a green plant which is synthesized food material. After synthesizing food material, the energy of food is transferred from trophic level 1 to trophic level 2. Actually, trophic level 2, which is occupied by herbivores, and trophic level 3 is occupied by carnivores, and trophic level 4 is occupied by tough carnivores, right? So here, right from trophic level 1 to trophic level 2, from trophic level 2 to trophic level 3, from trophic level 3 to trophic level 4. So the flow of energy which takes place from trophic level 1 to 4, that flows unidirectionally. That is called the energy flow, right? So this diagram clearly explains to you. Here you can see plants are producer. Producer always occupied in trophic level 1, and the consumer, they are nothing but rabbit, which are occupied at trophic level 2. It is designated by T2. They are the second structure, second level of ecosystem, and the third one is trophic level 3, from which the transfer of energy from one trophic level to finally trophic level 4 it reaches. Again, it is energy after death of trophic level 1, 2, 3, 4. After this top carnivores or the carnivorous plants are, when they are died, what will happen? The excess amount of energy also transferred from a living system to non-living system, which means the environmental soil which receives the food material again by means of decomposition process, right? Again, a decomposition process, again the plant which receives food material. Now this energy is a constant. Energy is a constant which is stable in nature, but the storage of energy and the transfer of energy is only varied from one trophic level to another trophic level. Actually, this can be explained by a thermodynamics law. The flow of energy can be explained by storage of food material in case of tissues and other living organism of a consumer. It can be explained by thermodynamics law. Actually, the flow of energy and storage of energy can be explained by thermodynamics law. According to thermodynamics law, there are two laws are there. The thermodynamics law, it is of two types. Thermodynamics law is the one, and the thermodynamics law two. Actually, the storage of energy can be explained by two thermodynamics law. According to thermodynamics law one, which states that energy is a constant or stable, neither energy cannot be destroyed, but one type of energy can be transferred from one system to another system. This is called a thermodynamics law 1. I repeat once again, thermodynamics law 1. According to that, it creates energy which is stored from one organism to another, which means the transfer of energy from one trophic level to another trophic level. But the energy is a constant, energy is a stable form. But one type of energy can be transferred into another another form of energy, but energy cannot be destroyed, neither created nor destroyed. This is called the universal law, right, of energy, right? The second law is thermodynamics law 2. According to this, when the flow of energy from one trophic level to another trophic level, only few amount of energy is transferred and the maximum amount of energy is lost after respiration in the form of heat. So for that, in order to explain the second thermodynamics law, let me take the 10% law, right? Actually, according to thermodynamics law 2, which out of 100% energy is synthesized in any trophic level, out of which only 10% is only utilized or transferred from one trophic level to another trophic level, whereas 90% of energy is lost in the form of heat. This is stated by thermodynamics law 2. According to that, it states that every trophic level, when the transfer of energy from one trophic level to another trophic level, the energy is only few amount of energy is only transferred and stored. Maximum a large amount of energy is lost in the form of heat. It can be explained by that is called 10% law. Actually, 10% law, it is similar to that of thermodynamics law 2. It was first proposed by Lindemann. The year of 1942. According to Lindemann, the sunlight, as I mentioned very earlier, sun is the main source of all the living system. Suppose 100,000 joules of energy is exposed or obtained by a producer or trophic level 1, the T1 or trophic level 1, in which the green plants are producer occupied. Producer always occupy the bottom of a trophic structure of an ecosystem, in which if 1,000 joules are given to trophic level 1, it only takes 10% is only taken, remaining 90% of joules are excited or lost in the form of heat, right? So let me take first of all 1,000 joules are given to the producer which utilizes only 10%. According to 10% law, if 1,000 joules are given, only 100 joules are trapped by producer. Again, this 90% of joule, that means 900 joules are excited out or it is emitted in the form of heat. This is called the 10% law. Again, from trophic level 1 to trophic level 2, T2 means trophic structure, trophic level 2, in which some rabbits are there, right? This is occupying the second level of an ecosystem, in which again out of 100 joules are transferred to T2, only the T2, the organism of T2, which receives only 10 joules only, according to 10% law, remaining 90% is excited. Hence, 90 joules are lost in the form of heat. Only 10 joules are utilized and stored in the organism of T2. Again, from a T2, from the transfer of energy from T2 from a T3, the transfer of energy when it occurs, when it transfers from T to T3, the amount of energy, only 1 joule is obtained from T2 organism, remaining 9 joules are excited in the form of heat, right? According to 10% law, right? Then finally, from 1 joule, according to 10% law, only 10% is only utilized and transferred from T3 to T4, remaining 90% is excited or lost in the form of heat. This is called a 10% law. I repeat once again, 10% law, according to 10% law, when the transfer of energy from one trophic level to another trophic level, out of 100%, only 10% of energy is only utilized and transferred from one trophic level to another trophic level. Finally, it reaches a 0.1 joule amount of energy. If 1,000 joules are given to trophic level 1 or a producer, this can be explained by 10% law. It was first proposed by Lindemann, right? Students, did you understand what is 10% law? According to 10% law, any amount of energy is given, only 10% is utilized and transferred from one trophic level to another trophic level. Remaining 90% is lost in the form of heat, right? So maximum amount of energy is lost after respiration, after biological process. So simply 10% is only utilized, hence it is known as a 10% law, right? So the flow of energy can be explained by 10% law, which was proposed by Lindemann in the year of 1942. Here you can expect write short notes on 10% law. Is that 3 more question? Or 10% law was proposed by dash. That is a 1 more question. If it is asked, you write Lindemann in the year of 1942. Or draw the structure, trophic level structure of an ecosystem according to 10% law. If it is asked, just to draw the structure, the bottom line shows T1, the second level indicates T2, and third level indicates T3, secondary consumer, and finally tertiary consumer, right? So this is an example for 10% law, right? Hoping that you could understand what is 10% law. The next we pass on to food chain. Next we pass on to food chain and types of food chain. Actually, now I'm going to talk about what is food chain and types of food chain. Actually, food chain is nothing but a moving of energy from one trophic level to another trophic level. As I mentioned, now this is a ecological structure or ecosystem. This ecosystem is nothing but the composition of T1 and T2 and T3 and T4, which means a trophic level 1 and trophic level 2 and trophic level 3 and trophic level 4. So here the food chain is nothing but a moving of energy from one trophic level to another trophic level in an ecosystem. This is called a food chain. So say for example, the food chain is nothing but the transfer of energy from a trophic level 1 to and trophic level 2. The food material is moved, right? So from T2 to T3, as a result, finally we can get the amount of energy from a T1 to T4 through T2 to T3, which means a trophic level 1 and trophic level 2 and trophic level 3 and trophic level 4. From trophic level 1 to trophic level 4, the movement of energy from one trophic level to another trophic level. For trophic level 1 indicates the producer and trophic level 2 indicates consumer, primary consumer, and trophic level 3 secondary consumer, and trophic level 4 tertiary consumer, right? So this is an organism which are occupied in different levels of ecosystem, right? So the food chain is broadly divided into two types. Food chain can be divided into two types. The first category is grazing food chain. The second category is detritus food chain. This is the first one, and this is the second category. According to grazing food chain, here a producer, or they are the green plants, or grass is a producer. While the producer of producing food material after by the process of photosynthesis, the food materials are transferred. Energy is transferred from one trophic level to another trophic level. Here, the second trophic level. Now, this is a structure, trophic level structure, in which T1 is the producer. Always a producer is occupied in first trophic level, and the second trophic level is T2. It is occupied by mouse. And third trophic level, it is designated by T3. It is occupied by snake. And for fourth trophic level, T4, it is designated by eagle. So the moving of food material, the moving of food energy from producer to mouse, from mouse to snake, from snake to eagle. So the flow of energy from trophic level 1 to trophic level 2 and 3, and finally it reaches trophic level 4. This is called a grazing food chain. Actually, grazing food chain, which begins with the producer in the form of grass, and which is designated by T1, and that food material is transferred to trophic level 2, that is mouse. From mouse to the food materials are moved or transferred to snake, that is a trophic level 3. From trophic level 3 to the food materials are totally transferred to trophic level 4, that is eagle. So the flow of energy from rice, right from a grass to eagle, this is called a grazing food chain. Sometimes the question it's going to be asked in an examination, what is a grazing food chain? Or explain grazing food chain, right? Or illustrate grazing food chain. If it is asked just to start with the producer in the form of grass, primary consumer in the form of mouse, and secondary consumer it is in the form of snake, and tertiary consumer it is in the form of eagle, right? So all these organisms are represented by T1, T2, T3, and T4. So this is called a grazing food chain. Actually, grazing food chain begins with the living system and ends with the living system, right? And different food chain, they are nothing but the food chain. The moving of food material begins with the dead matter, dead organic matter, and ends with the living matter, living organism. So this is a major difference between grazing food chain and detritus food chain. I repeat once again, detritus food chain is a kind of food chain that begins with the dead organic matter to living organism. That is called a detritus food chain. I repeat once again. Now this is a trophic structure. It is designated by T1. Here T1 producer is also absent instead of producer. The fallen leaves are there. The fallen leaves or considered to be as here producer, which are dead matter, dead organic matter. From dead organic matter, the food materials are transferred from trophic level 1 to trophic level 2. The trophic level 2 which occupies earthworm. Here earthworm is there. Earthworm which occupies, which is considered to be as a consumer, right? I can say primary consumer. From the primary consumer, the food materials are transferred to blackbird. The blackbird is nothing but they are the secondary consumer. From the secondary consumer, the food materials are transferred from blackbird to eagle or what? That is called a carnivore, is a top carnivore, right? So this is called a detritus food chain. Actually, this is a fourth trophic structure is designated by I think top carnivores. This top carnivores from a detritus, I mean the pollen leads to top carnivores. The transfer of food or the moving of food material from dead organic matter to living organism. That is called a detritus food chain, right? I repeat it again. Food chain can be divided into two types. One is a grazing food chain, another is a detritus food chain. Grazing food chain starts with the living system and ends with the living system, whereas the detritus food chain begins with the dead matter and ends with the living organism, right? This is the major difference between grazing food chain and the detritus food chain. Next, we pass on to food web. So next we pass on to food web. Actually, food web is nothing but there is a interlocking patterns of various levels of organism. That is called a food web. The flow of energy which takes place in different directions. That is called a food web. Food web is nothing but there is an interlocking patterns. There is That is the interlocking patterns of food energy from one trophic level to another trophic level, which forms like a web-like structure. There is a interlocking patterns of food energy, which forms like a web-like structure that is called a food web. I repeat once again, food web is nothing but there is interlocking patterns of different food energy from one trophic level to another trophic level, right? That is called, that forms like a web-like structure or arrangement. This is called a food web. Now, food web can be explained by this illustration. Now, here the green plants are producer. This is a producer or trophic level 1. T1 is nothing but a producer. Producer is nothing but which are able to synthesize its own food material, and food materials are transferred generally from a T1. Transfer of here you can see different patterns of organism. There are various organism or interconnected in a ecosystem that forms like a web-like structure. So directly these rabbit which gets the food material from directly from the plant, and mouse also which gets directly food from the grass or a producer, and the lizards or the leaf grasshopper, it also obtains, takes food from a producer. From the producer, the food materials are transferred from plants to grasshopper, from plants to mouse, from plants to rabbit. From grasshopper to the moving of energy are transferred to lizard. From lizard, the food materials are transferred to that is top carnivorous. Here, that shows one type of patterns of organism, and on the other hand, you can say the food material is obtained by mouse, which is always occupied by a trophic level 2. From trophic level 2, which gets transfers food material to snake. From snake to the food materials are transferred to Maha. So this diagram explains very clearly there is interlocking patterns of various organisms, which food materials are transferred from one trophic level to another trophic level and forms like a web-like structure that is called a food web, right? What is the significance of food web? So next we must know significance of food web. Actually, this food web construction which helps to describe the patterns of various living organisms in an ecosystem. Now, ecosystem is nothing but there is a trophic level structure in which a living and non-living organism which are interrelated with each other. That is called a ecosystem, right? So there are two main components of ecosystem, living and a non-living component, right? You know very well. So simply, the first point always it to describes various patterns of organism. So there is a food web which constructs very clearly the patterns of various food chain. Second point. It is also used to illustrate the direct and the indirect relationship of different organisms. I repeat once again here, plant is there, and grasshopper is there, and lizard is occupied, and rabbit is occupied in second trophic level, and mouse is also found in second trophic level T2, and snake is also found in T3, and finally top carnivore. So this diagram explains very clearly. There is a direct relations and indirect relations between different patterns of organism, right? This is the second point. And third one, it is also used to study our different organism in a food web, right? So here it helps to know the various type of habit and habitat of organism. Here mouse is there, rabbit is there, lizard is there, and snake, worm, and plants are also, right? So this is simply something about food web, significance of food web, right? So simply it explains the different patterns of different interlocking patterns of organism, and it also helps to describe various species which are interconnected with each other, and it is also used to illustrate direct and indirect relations between different kinds of organism which are interconnected in a trophic level structure, right? So this is a significance of food web. Next we pass on to ecological primates, or it is also nothing but Elton's primate, because it was first introduced by Charles Elton in the year of 1927, and it is known as the Elton's primate. Next we pass on to next we pass on to ecological primates. Actually, ecological primates are nothing but there is a graphical representation of organism, various organism at every trophic level, right? So this is called ecological primates. Ecological primates, nothing but it is a diagrammatic representation of various levels of organism. How these organisms are occupied and how it is interconnected with each other, and how the energy or a number of organisms and the biomass and the energy flow, how it is varied from one trophic level to another trophic level. Simply the diagrammatic representation of trophic levels of various trophic levels, that is designated by ecological primate. So this ecological primate is can be classified into three types. The first type is primates of number, and the second category is pyramid of biomass, and third one is pyramid of energy. The first category pyramid of number, and the second category is pyramid of biomass, and third category is pyramid of energy. So ecological pyramid can be classified into three types. The first type is pyramid of number, the second type is pyramid of biomass, and third category is pyramid of energy. So this classification was first given by Charles Elton, and it is known as Elton's in the year of 1927. Hence it is known as Eltonian's pyramid, or it is also known as ecological pyramid. Ecological pyramid is also called as Eltonian pyramid because it was first introduced by Charles Elton in the year of 1927. Hence it is known as Eltonian pyramids, right? So first of all, let me take pyramids of number. Then we will come back a pyramid of biomass and the pyramid of energy. I'm talking about First of all, pyramid of number. Here, there are so many numbers are there. There are different ecosystems. First of all, let me take a grassland ecosystem, GE. G is nothing but grassland ecosystem. And the second one, P, pond ecosystem. And the third one, FE, forest ecosystem. Then finally, parasitic ecosystem. Your ecosystem, it is classified into following types based on number of organisms. The fourth category is parasite ecosystem. So here you can see there are 4 different types of pyramids which are designated by different organism occupied. So the first of all, let me take a grassland ecosystem. So always T1 is a producer. The number of organisms is higher than that of T2. Actually, producer larger number of producer occupied T1 and T2 as compared with T2. The organisms are very few in T2 or trophic level 2. In an ecosystem, as compared with T1, it is a lesser, right? So, as compared with T3 with T2, the organism is very, very few in number. There are lizard and snake is there. And finally, T4 is designated by eagle, that is occupied as a T4 trophic level structure. So, there is a graphical representation that states there is a gradual decreasing of organism from one trophic level to another trophic level. So the number of organisms are decreased from one trophic level to another trophic level. This is called always a grassland ecosystem, always upright. So the G is always upright, which means there is a gradual decreasing of organism from one trophic level to another trophic level in case of grassland ecosystem. I'm talking about second ecosystem, that is a pond ecosystem. Here pond ecosystem also there is a gradual decreasing of organism from a T1 to T2, from T2 to T3, from T4. So here also you can see there is the number of organisms or decreased from trophic level 1 to trophic level 2. Trophic level 1 is very wider because it consists of phytoplanktons, producers, many microorganisms also present in case of T1. And metazoa also present. And T2 organism which are occupied T2 structure, they are lesser than that of T1. And the T3 organism, small fish and small insects also present, which are lesser in number as compared with T2, and finally there will be large fishes. So as compared with the T4 with the T1, there is a gradual decreasing of organisms. So simply, it is a diagrammatic representation that indicates, that explains very clearly the number of organisms gradually decreased from one trophic level to another trophic level. This is called a pond ecosystem. Always pond ecosystem is also upright in condition. And third one, forest ecosystem. I'm talking about forest ecosystem is nothing but now this is a spindle shape. It's very special type because in forest itself, producer is nothing but tree is only producer. T1 is nothing but trees. The trees that consist of a tree can be fed or eaten by elephant and fox, birds. So many organisms are present in T2. So as compared with the T2 with the T1, the T2 organism larger than that of T1. Now this is a T1. T1. Now this is only one organism, that is a tree that consists of a consumer. There are many consumers who are visiting such a tree. From a T2, the number of organisms or lesion, that means the consumer or fed or eaten by in forest by some organism. They are the fox and snake or etc. So they are called T3 or trophic level. And finally, top carnivorous, nothing but lion. Lion is a king of forest, so now only one organism. So the T4 and the T1 are lesion. The number is very few. So T1 and T4 are only one number, and T2, T3 are designated by different number of organisms which are occupied in every trophic level of organism, right? Hence it forms like a spindle shape. The spindle shape of structure is related to dash ecosystem. If that is a question, if it is asked, you can write A, grassland ecosystem, B, pond ecosystem, C, for forest ecosystem, and D, parasitic ecosystem. Always the forest ecosystem is a spindle shape. The next one, for the time, there is a parasitic ecosystem. So there is a gradual increasing the number of organisms. It is opposite to grassland ecosystem and the pond ecosystem. Hence, it is inverted in nature. So always this parasitic ecosystem, it is always inverted in condition, right? So this is simply something about pyramids of number. Pyramids of number, it is dealt by different system. They are the grassland ecosystem, pond ecosystem, and the forest ecosystem, parasitic, among which grassland and the pond ecosystem are always upright. And the forest ecosystem is a spindle shape, that is a very special type, and parasitic is an inverted one, right? Please remember, parasitic is the inverted. The next we pass on to pyramid of biomass. Now next we pass on to pyramids of biomass. Here also let us take grassland ecosystem, forest ecosystem, and pond ecosystem. Here G refers to grassland ecosystem. There is a gradual decreasing right from a T1 order to T2, T3, T4. So simply it stands for these pyramid of biomass. There is a gradual decreasing of an organism from one trophic level to another trophic level. Hence it forms like a upright in condition. Because the amount of the quantity of biomass is decreased from producer to consumer, from consumer to primary consumer, from primary consumer secondary, from secondary to tertiary. So as a result, we can get right from trophic level 1 to trophic level 4, there will be decreasing of biomass. That means that the quantity of food material or decreased from one trophic level structure to another trophic level, hence it forms like a upright in nature. The next one, forest ecosystem. Actually, forest ecosystem, it is also this is called the forest ecosystem. Producer, I think that trophic level 1 is a larger number. That means the quantity of biomass is higher in case of T1, and in case of T2, there is a gradual decreasing. And in case of T3, this is also consists of very lower amount of biomass. And finally, T4, it also consists of very least amount of biomass. So there is also decreasing of biomass. That means the quantity of biomass from one trophic level to another trophic level. Next to last, that is a pond ecosystem. Always a pond ecosystem is inverted in condition because the producer, I think trophic level 1 is there is a number. There is a number is only one number, and when you go for a trophic level 2, the number of the biomass is increased in order. So there is an increasing of the biomass from one trophic level to another trophic level, right? So hence it forms always a inverted in condition, always a inverted in nature. This is a T3 and this is a T4, right? So there is an increasing of biomass from one trophic level to another trophic level. As a result, this pyramid is inverted in condition, right? So next we pass on last pyramid of energy. This is the last topic. The last topic is actually pyramid of energy. There is a decreasing of food energy from one trophic level to another trophic level. And it can be explained by 10% law. Already we have discussed about. So let us take the 10% law or thermodynamics law 2. That is the most suitable example for pyramids of energy. So always the transfer of energy from one trophic level to another trophic level, and it is there is a decreasing of energy from one trophic level to another trophic level, right? So simply it forms like a always upright. In any type of ecosystem, whether grassland ecosystem or pond ecosystem or forest ecosystem, or if you take any type of ecosystem, the pyramid of energy is always upright because there is a gradual decreasing of energy from one trophic level to another trophic level. It can be explained by 10% law, right? So this is simply something about ecological pyramid. So far we have discussed what is energy flow and what are the types of thermodynamics law. Then what we discussed 10% law. Then next we discussed the food chain and types of food chain. Then we have discussed about the food web and the significance of food web. Then finally we discussed ecological pyramid. It is a pyramid of number and pyramid of biomass and pyramid of energy, right? So thank you for joining. When you come to next class, try to make an assignment regarding this topic and try to send it to your respective subject teacher, right? If there is any clarification, ask. Students, thank you for joining.